The next problem is 46th. A pendulum of length L is suspended from the ceiling of a car moving with a speed V on a circular horizontal rod of radius R. Find the tension in the string when it is at rest with respect to the car and find the time period of oscillation. So see, in this problem what we are asked is, we have again given a car. So suppose this is, we consider this as a car, so like that you can consider, and one of the pendulum is suspended from the ceiling of this particular car. So it is like this, and it is given that this particular car is moving on a circular road. So you can consider it like this, that this car is moving in this particular direction. So by that time what will happen is, if it is moving on a circular horizontal road, by that time what we can consider is like this, that suppose this is the pendulum which is suspended from the ceiling of the car. So it is like this, and when it is moving over a horizontal circular road, so if it is doing a circular motion, by that time what will happen is 1 mv square by r force tangentially will act on this particular bob or on this particular mass. So that particular force will be like v square by r. So a tangential force or a tangential acceleration equals to v square by r will act in this particular direction, and there will be a mg force or g acceleration you can consider. So here if you want to consider the force, by that time you have to consider it like m into a or mv square by r. So better to consider in terms of acceleration only. So let us erase the mass term here. So from both the terms we will erase the mass term, only we are considered about the acceleration. So we are considering it like this. So this was our direction for v square by r. So what we can say here is, again we have to evaluate the g effective, or first term what we are asked here is, find the tension in the string when it is in rest with respect to the car. So first part we have to evaluate the value of tension, and the second part will be the time period of the. So for the first part, in order to evaluate the tension, we have to consider a different view for this particular situation in order to understand it more better. That is, suppose when the block is on rest or when the car is not moving, so it will be like this, means it is on the rest track. But when it starts moving in a circular track or over a circular road, by that time what will happen is it will just move like this. So suppose this is the if it is in rest direction, so it will be like this, but when it is moving on a circular road, by that time it will deflect like this. So if it will deflect like this, by that time what will happen, that when it is going on a circular road, so a tangential force along that circular track will act in this particular direction. So by that time mv square by r force will be in this particular direction, and the tangent and the force due to the gravitation will be vertically downward or vertically downward direction from the mass of the bob. So mg force will be in this direction, and v square by r force will be in the tangential direction to the circular track. So these two forces will act there. So by that time we have to calculate the resultant force due to these two forces. So the resultant force will be like, see, this is the mv square by r force, this is the mg force. So these two forces resultant will act in this particular direction, that is in the direction, along the direction of the tension or along the direction of the string. So what we will see here is, now we have understood, so we will just erase this drawing. Hence the net value of tension will be here like M into A net or A resultant. So A net will be like under root V square by R term. So V square by R term you have to take whole square, and again you have to add G square term here. So this will be the value of A net. So by that time the value of tension will be like A into under root V square. So V square, so V power 4 will be there, and R square plus of this value G square. So this is going to be the value of tension. So this should be our answer for A part. So M into A terms, where A value is again written here. So it is like this only. So yes, we have evaluated the value or answer for part A. Next will be our part B. So in the part B, what is asked is find the time period of small oscillation. So again we have to evaluate the value of oscillation. So what it is now very easy, that is 2 pi under root L by, again we have to write G effective. So G effective is here 2 pi under root L by, so 2 pi under root L by, G effective is here like V square by R whole, you have to consider as a square, and G square is there. So it will be the time period for small oscillation. So this should be the answer for part B. So part B answer is again correct. Here it is written in terms of A, and further the value of A is given. So we have calculated the